estimator. What is a good estimator? For a good estimator, it has to be unbiased. So if you have more than two estimators, and one is, if both are unbiased, okay, then what's the criterion to choose a better one? The criterion is efficiency, and efficiency is smaller variance, okay? But now the question is, suppose you have one unbiased estimator, but the variance is higher, and the other one is biased, but the variance is smaller. So in this case, how are you going to choose? One is unbiased, but variance larger. The other one, biased, okay, but the variance is smaller. How are you going to choose? The way to choose it is to use MSE. Okay, MSE is mean square error. Okay, mean square error. So now what is mean square error? So let us say the estimator is equal to theta. Okay, so this is the estimator. And true value, okay, true value is equal to mu. Okay, true value is equal to mu. And so we have to find out the MSE, okay, for these estimators. And what is that? So MSE, okay, of theta hat. Okay, what is that equal to? Okay, it is equal to expectation theta hat minus theta square. Okay, so MSE theta hat, it is equal to expectation theta hat minus theta square. So actually what is this? Expectation x minus mu x. This is the true value, right? And x is the estimated, okay? X minus mu x. But here we have different interpretation. It is MSE, okay? It's no longer the variance. Okay. So what is this? We expand it, okay? And now how to expand it? So we have expectation theta hat minus expectation theta hat plus expectation theta hat minus theta square. Okay? So this is equal to this, right? Because you have theta hat minus theta, okay? And here you have minus expectation theta hat plus expectation theta hat, right? So basically this is the same as this one. And now we're going to expand this one. Okay? Okay, what do you get? Expectation, okay? You have theta hat minus expectation theta hat, okay, square, okay, and plus 2 times theta hat minus expectation theta hat times expectation theta hat minus theta, okay, and plus expectation theta hat minus theta, okay, square. So basically this is A plus B, right? A plus B square. So you have A square plus 2AB plus B square, right? Okay, so basically, it is just a very simple manipulation here. Okay, and what you get? You get expectation of theta hat minus expectation theta hat square, okay, plus 2 times expectation, okay, because there is an expectation here, right? Expectation, okay, expectation, and then you have theta hat minus expectation theta hat times expectation theta hat minus theta, okay, and plus expectation of expectation theta hat minus theta, okay, square. Okay, now you've got to be very careful. First, you have to know do you know expectation theta hat equal to theta? No, you don't. Because if expectation theta hat equal to theta, what is that? That is an unbiased estimator, right? But in this case, it is a very general estimator. Do we know if it is unbiased? We don't know. Okay, we don't know whether it is unbiased or not. Okay, here in this case, we don't know whether it is unbiased or not. So you are not sure of this. Okay? But what is this? Because we don't know whether expectation theta hat is equal to theta or not. So what about this? This is the estimation error, right? Because this is the estimation on average. And this is the true value, right? So here, what is this? This is what we call bias. Okay? Bias means error. Okay? Basically, bias means error. So what is this? This is equal to, okay, so let us simplify all these terms one by one. Okay, let us try to slow down. Simplify all these terms one by one. First, let us look at this. So here, it is a value, right? This is supposed like x. And what is this? Expectation x. So this is like x minus mu x, right? Theta hat minus expectation theta hat. X minus expectation x. So what is this? This is variance, right? So this is variance theta hat. Okay? And for the second part, we already talked about it, right? It is bias. So it is bias theta hat, okay, square, okay? And what about here? What about here? Here we have to further simplify it. First of all, you want to be very careful. Is this one equal to this one? Not necessarily, right? Because we say only if, okay, only if this is unbiased, will this one be equal to this one, right? But is it unbiased? We don't know, okay? Then what about this one? Is this one equal to this one? We don't know either, but, okay, you have what? Expectation, right? So let me erase this part here. Okay, so we have expectation theta hat minus expectation theta hat. Okay, and here you have expectation theta hat minus theta, right? Okay. So here you have expectation. This expectation going to move into it, right? So then you have expectation theta hat minus expectation theta hat. So for this part, what do you get? Actually, expectation of theta hat is the mean value of theta hat, right? And what about here? It is also the mean value of theta hat, right? This is a constant. Will expectation, the operation of expectation, affect a constant? No. So this will be expectation theta hat. And what about here? Also expectation theta hat. So because of this part is equal to 0. So then what you get? You have MSE theta hat is equal to variance of theta hat plus bias of theta hat squared. Okay? So of course, if two estimators, if both estimators are unbiased, then we are looking for efficiency. So we will choose the one with smaller variance. Okay? But what about here? Suppose you have two estimators. One is biased, okay, but smaller variance. one is unbiased but larger variance. Okay, what you're going to choose? The criterion to choose which one is by this variance plus bias square. Okay, so if these two things put together for anyone is smaller MSE, then we choose that one. Okay, so in this case you consider two components. The first component is variance. The second component is bias square. Okay, so if you're going to choose which one is a better estimator, you're going to based on MSE. Okay, based on MSE. The smaller the better. Okay, the smaller the better. Okay, so we're going to get to this point, and next week we're going to discuss blue, that's best linear unbiased estimator and maximum likelihood estimator. Okay, see you next week.